In this video, we look at the start of the questions from exercise 3.6 on page 100. So a z-score less than or equal to 1.6. Draw your curve. Put your 0 on. 1.6 is up here. So the arrow is pointing to the left. So you can see we're looking for the information to the left of the line. So we go to our normal distribution table and we find 1.6. 1.6, 0.9452. 0.9452. The next one is between two numbers. So just draw a sketch again. They're both positive this time. So our 0, so our 1 and our 2. So we're looking for in between the 1 and the 2. I'll just change color in for between the 1 and the 2, between these two lines. What amount of information or amount of data is stored in that sector. So if we get from 2 all the way back and then from 1 all the way back and get the difference between them, it'll be what's left in between. So the probability of 2 is equal to, go across to your z-scores, 9772. 0.9772, so 97.72% of the data is to the left of 2. What about to the left of 1? 8413. The probability of 1, 0.8413. And the difference between these two numbers, you can probably see, is 13, 84, 97, 13, 59. So 0.1359 is what's left in between. Again, we have now a negative and a positive, so it covers all bases here with these types of questions. So we've got our curve, we were 0, we have a minus, I'm going to move it to the left here, minus 1.645 and plus 1.645. So how much data is represented by this part of the curve? So we go and try and find 1.645, 1.6, and this is the 4 and the 5, and you can see here, why are they saying 645? Well, that's 64 to the left and 65 to the right. So 645 in between is going to give exactly 0.95. You can see here 95 and 5, there's the same either side. So 0.95, what's that going to tell us? So a z-score of 1.645 gives us 0.95. So that means that 95% of the data is all the way down here, which means that left in the tail is 5%, which means the other tail would also be 5% because they're about 1.645. So if the tails are 10%, the bit in the middle, which is what they were asking for in between the two values, is 90%. So the answer to this one will be 0.9 or 0.90. Okay, just two more should cover all of these types of questions that can be asked. Okay, so what about between minus 1.2 and minus 1.1? So there's only a tiny bit in there. We could do it between 1.2 and 1.1 if you wanted. You could use the positive part of this curve, but I'm just going to use the negative part here, but it doesn't really matter where you draw it. It's going to be the same answer because of symmetry. Just going to try and make the bottom a bit thicker. So we have a point here and a point here. Minus 1.2 and a minus 1.1. I think it's easier just to get the two values. Get 1.2, get 1.1, and see what the difference is between them. So 1.2, 8849 and 8643. All right, 8849 and 8643. 8849 and 8643. Always double check when you're writing a lot of numbers down. So what's the difference between these? It looks to be about 206, isn't it? Yeah, 43 and 49, 600 and 800. It's 206. Don't forget the first 0. So the answer to this one is 0.0206. And if you've watched the first video, you should know the answer to this one. This is the rounding off of the empirical rule, 2 standard deviations of either side. So when we go to 1.96, what are we going to see? We should see 97.5% jump out at us to have 5% in the tails. So let's have a look. 1.96, 1.9, 6, 0.975, which is what we were looking for. So draw the sketch. 0, 1.96 and minus 1.96. We're looking for the bit in the middle. What did we say the tails were going to be? 2.5% each in here and in here. So the tails are giving off 5% of the data, which leaves 0.975.